Okay, is it 9?
Yeah, it is 9. How did you do this?
So like we don't really need the depth for this problem. So I did like the volume displaced, which is like the volume after like the thing is like pi big R squared height. And if you substitute 12 and 6.75, you get 972 pi centimeters cubed. And then the volume
Volume
of
displaced should be equal to big R
nine
square into 10.
no R squared into H.
Why?
Uh,
Where would the pi go?
oh, pi is like before the yeah there.
Mhm.
And then you substitute 12 and 6.75 and you get 972.
Equal to pi r cube like this. So,
Yeah, something like that. 972 pi equals 4 over 3 pi r cubed.
okay, this is correct one. So, this was one of the methods through which you can solve this question now. Uh, but what about the proportionality method? See, the radius of the whole cylindrical vessel is not going to change, right?
Mm-hmm.
Cylindrical vessel's radius is going to be as it is, just as its height is increasing. So, volume of the cylindrical vessel depends only upon height, right?
Yeah.
So, we can say initial volume upon final volume would be equal to initial height upon final height. Am I right? And if
Yeah.
we are going to just subtract both sides by 1, we can do this on both the sides, right?
Mm-hmm.
It means the change in volume, okay, change in volume upon the final volume of the whole thing is going to be equal to the change in height upon the final height, right?
Yeah.
Okay. It means change in volume would be what? The volume of spherical balls, right? Because the volume that would be increased, that would be totally because of the spherical ball, right? So this would be volume of spherical ball. Okay,
Yeah.
this is given as 6.75. So we are going to substitute this thing. What would we get? 4 upon 3 pi r cube, right?
Yeah.
Yeah, should have been not pi r cube, but
Oh
1 pi r upon what would be final volume? Final volume of the cylinder. It would be pi r square into h. What is h? H final would be equal to 6.75 upon h final. Again, h final will get cancelled out. So r pi would also get cancelled out. R cube would be equal to 3 upon 4 into 12 square into 6.75. And when we are going to solve out from here, this would come out as 9 centimeters answer. Okay. So again, with the proportionality method, the answer is coming out to be the same, right?
Mm-hmm.
But applying the proportionality method, you have to like keep in check that the terms that you are writing is in terms of what? Here, volume of cylinder was used, so both these volumes are cylinders only. But we had to make use of the given data also. It means we had to make use of the increased volume. So volume increased would be given by delta V, which is nothing but V final minus V initial. So we have had to create this term. That is why we have subtracted both sides by 1 like this. Okay.
Mm-hmm.
Sorry. Let me insert the another question. Try this out.
Okay. I got 14, I think.
Yeah, that's correct only. So, like, did you solve using the, like, what equation did you write? Just tell me that.
I first did the volume of the hollow sphere,
Mm-hmm.
which is 4 over 3 pi times r, big R cubed minus little r cubed. And we have the diameters as 4, 8 and 4, which means the radiuses are 4 and 2. So then you get 224 over 3 pi. And then you just, the volume of the cone is 1 out of 3 pi r squared height. And then the radius is 4. So 1 over 3, 4, 16 over 3 pi h is equal to 224 over 3 pi. And then you can just solve for h.
Whenever one shape is remolded to form another shape, 3D shape we are talking about here. So you just have to equate the volumes. You have to apply volume conservation. Means volume of the first shape is equal to volume of second shape. Okay?
Yeah, I did
So
that.
directly this equation. Here you have like first of all calculated this volume, hollow sphere's volume. Then you have like written the formula for the cone's volume. Then you have
Yeah.
made them equal, right? But instead
Mhm.
of that, what you will do, you will directly write like this: 4 upon 3 pi r cube minus r cube would be equal to 1 upon 3 pi r square. R square would be 4 square into h. Okay, directly this. So
Okay.
that all the terms which would be prone to like cutting out from both the sides, that would just simply cut out, and you'll have directly the value of h. So uh, 4 cube minus 2 cube upon 4, which would come out as, I guess, 64 minus 8. That will give us 56 upon 4, 7. No, 14. Yeah, 14 centimeters. That's, okay. Directly equate the two volumes. Like,
Okay. So
don't
no.
calculate volume separately. Directly equate the two volumes. Volume conservation. Because whatever volume of the metal or the substance used to make out the first shape, that is exactly what we are going to use to make out the second as well. Second one as well. Right?
Mm.
Okay. On to the next one. Hmm. Try this out.
a second. Is it 50%?
Yes, it is. Okay. On to the next question. Try this out. Again, directly equate the volumes.
Okay. Is the edge the diameter? Oh, it's a cube. My bad. I thought it was. Never mind. Is the first question 25,088?
The answer for this one you are getting as 2588.
Yeah, 25,088.
20,
25.
25088.
Yeah.
Okay. I guess that is not it. Let's see. So what I have told you, just equate out the volumes, right? So how many spherical bullets can be made out of a solid cube of lead hose? Okay. So volume of this cube would be equal to what? 44 into 44 into 44, right? Let's say we are making uh, like n number of bullets, okay? And each one's volume is going to be 4 upon 3 pi into r cube, 2 into 2 into 2. Okay,
Okay.
so we have written this equation only.
Yeah.
Okay, so this 4 will cancel out this 11 times. Again, this 4 will cancel out this 11 times. This 2 will cancel out here 22 times. So n will be equal to uh, 22 into 11 into 3 divided by pi. This is going to give us 2542 answer.
Okay.
Okay, so 2542 would be the answer for this question. Okay, directly equating out the volumes. I'm not going to write anything because the one thing, one figure, one shape is going to be like remolded down into other shape. Okay, so if this is the equation that you have written, then how did your answer came out to be 25080?
I don't know. I think I just typed in something wrong or something.
Okay, okay, no problem. Okay, try this out now. Try this out.
Do you want it in grams or kgs?
See, like the density is given in terms of what? Grams. So if the answer is coming out to be too large, so that it can be converted down into kgs, you can give in terms of kgs as well. No problem.
So I got actually never. I got 3.8 something.
Yeah, 3.845 kg. Yeah, that is
Yeah.
correct only. Okay. On to the next one.
Okay.
Okay. You know the formula for diagonal of a cube, right?
Yeah. A root 3.
Yeah. Do you know how is it derived?
Isn't it like L squared plus W squared, but all of them are the same?
No, 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 that is not it. See, let me insert down figure for you. First of all, let me insert down the whole question. So, so the length of the longest rod that can place in a room of dimensions this. Okay, here it is a cuboid, not a cube. But again, we are going to apply the same formula under root 10 square plus 10 square plus 5 square. So like while
15.
writing the formula, we write like this. Okay, under root a square plus b square plus c square. Okay, but that is not how it is derived. So say for example, we have a cube, something like this. Or it can even be a cuboid. Okay, both of the discussions are going to go the same way.
Okay.
So it is a cube or a cuboid. Say for example, here we are taking it to be a cube only, where this is L, this is B, and this is H, right?
Mm-hmm.
So now, first of all, let's calculate the diagonal of this square or this cube. Okay, this length. What would be this length?
Root L squared plus B squared.
This would be under root L square plus B square. Okay, now, now in this triangle, if we are seeing, from this point to this point would be the diagonal of the cube or cuboid. Okay, right? From
Mm-hmm.
this point to this point, something like this is going to be the diagonal. And this diagonal length we have to find out. Now, in a cuboid, we know that all the faces are individually perpendicular to each other, right? It means
Yeah.
this face would be perpendicular to this face. Am I right?
Yeah.
And if that is the case, then every line, every straight line in this plane like this, that would also be perpendicular to this plane, right? It means
Mm-hmm.
any line lying in this plane, say for example this, would be perpendicular to this line. Any line lying in
It's
this plane.
cross section.
Yeah. Because both of the planes are perpendicular, it means any line lying in any of the planes are also going to be perpendicular to each other. So this is also making a 90 degree something like this, where this the two sides which are perpendicular to each other measure h and under root L square plus B square respectively. So the length of the hypotenuse or the length of the diagonal would be, according to Pythagoras theorem, it would be under root h square plus under root L square plus B square whole square. Okay, that is why it came out to be under root L square plus B square plus F square. Okay, that is how it is derived. This thing we are talking about. Okay. So
All right.
again, here in this question, it is going to be under root 10 square
100.
plus 10 square plus 5 square. It means
2G.
under root 225, 15 meters.
Yeah.
Okay, for this question. Let me insert another one. So now anyone, if someone says to you that derive in front of them, then you can do so, right?
Yeah.
You have to assume the figure like this. the longest diagonal. Okay, and to calculate it, you are going to use Pythagoras theorem, and for that you need a right angle triangle where this becomes hypotenuse, and that is going to be it by like using this diagram. Okay, even you can do it something like this from here to here, and using this triangle. Okay, it is going to be the same again because this diagonal would be under root L square plus B square as well, right?
Yeah.
From here to here. Okay.